The data on the right represent the number of live multiple delivery births, 3 or more babies, so we consider multiple delivery births here, in a particular year for women 15 to 54 years old. We want to use the data to answer the questions below. So first question here is we want to determine the probability of randomly selected multiple birth for women 15 to 54 years involved a mother 30 to 39 years old. So this is involving 2 different categories here. So we're looking at 30 to 34 and then 35 to 39. So first of all, we need to look at the total to look at this problem. So we want to find the total, so we need to sum up those values. So let's do that. So we're looking at 95 plus 513 plus 1633 plus 2838 plus 1845 plus 372 plus 119. Our probability there is 7 for, or our total there is 7 for 15. So what we have here, probability of 30 to 39, so a woman can't be in the category of 30 to 34 and then 30 to 35, so these are mutually exclusive, so I don't need to worry about subtracting out the overlap, so we're just going to add those 2 probabilities together. So we have 2838 over 7415 plus 1845 over 7415. So I can just add those 2 numbers together and put that over that. So 2838 plus 1845. So 4683 divided by 7415. I'm going to do math, enter, just to make sure that doesn't reduce, and it doesn't. So our decimal approximation there is 0.6316. So we're going to round up there since the digit after that is 5 or greater. So part B, we want to know the probability of randomly selected multiple birth for women 15 to 54 years old involved a mother who was not. So now that we found that, we can just use the complement rule. So not 30 to 39, we're just going to do 1 minus the probability of 30 to 39. So we're going to use the fraction here to be the most accurate, so we're going to do 4683 over 7415. Here, 1 minus, kind of a rule of thumb, I always put my fractions in parentheses. That saves some trouble to avoid any issues there. Enter, I'm going to do math, enter to get my fraction there. Another way to do this was to add up everything, but that would take more time. And I'm just going to write my approximate decimal underneath this here. So 0.3684. Okay. So moving along to the next one, we want to look at determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was less than 45 years old. So if we come up here and we look, oops, I'm gonna do this. So we're talking about less than 45 years old. Well, that's every category except this bottom one here, right? So that bottom category is the only one. So it's going to be easier to use the complement rule. So we're going to remember that the 119 there. All right, so we're going to do less than 45. So we're going to do 1 minus the probability that they're 45 to 54. That's going to be the easiest way to do that. So 1 minus 119 over 7415. Again, 1 minus parenthesis 119 over 7450. Enter, math, enter. There's our fraction answer. And then our decimal approximation 0.983, and then this is a 5, so that would round up. So this is actually going to be 0.9840 there. And then our last question, we want to find the probability that the mother was at least 20 years old. Let's write that down. Probability of at least 20. So let's scroll back up to our table here. So at least 20, so that's everything down. So again, the easiest thing to do here would be to look at the complement and use that top one of 95, because at least we would be looking at these bottom categories and adding all of those together. So let's use our complement again here. So we're going to look at 1 minus the probability that they're between 15 to 19, so that's going to be 1 minus, there's 95 of them out of 7415. So again, 1 minus parenthesis 95 out of 7415. Oops, I missed a number there. 7415. And then math, enter to get our fraction. And then you'll notice that one's reduced there. It's a big percentage. And that is approximately there, 0.9872 there. All right.